So the second part of dividing polynomials in 4.3, we are going to do what is called synthetic division. Now, for the most part, I will tell you that most students will thrive a lot better with synthetic division than they will long division, because it's a lot shorter, it's a lot quicker, and things like that. But at the same time, you can't use synthetic division like you can every single time with long division. Okay, remember, long division is like the quadratic formula of division. Okay, you can use it anytime. There's never a time that you can't use it. Synthetic division, though, there is only specific times that you can use this. Okay, so what I would put is the only time somewhere where it says examples, the only time we can use this is only when dividing by a linear have enough room? Yes, I do. Expression. So what does that mean? Okay, and if you have to underline it, capitalize it, circle it, highlight it, whatever you have to do to make sure that you only use it whenever you're dividing by a linear expression. So what does that mean? Basically, you can only use this whenever I'm dividing by something that has an x power of 1. If it has anything other than 1 as your largest power, you cannot do synthetic division. And trust me, I will still have people that will try. Okay? The only time you can use synthetic division is when, if you notice, that is to the power of 1. The x is to the power of the 1. The x here is to a power of 1. And x has a power of 1. That will be the only time you can do this. You cannot use synthetic division whenever you have an x squared, whenever you have an x to the third, whenever you have an x to the fourth, whenever you have an x to the 10th, and everything else in between. It's only when the power for your x is 1. Did I make myself abundantly clear by saying that multiple times? Judging by your silence, I'll take that as a yes. So, what makes synthetic division so much easier is that you really only have to be able to do two things. You have to be able to multiply. I guess 3. You have to be able to add or subtract. If you can do those three things, you really don't even have to divide. Okay? If you can multiply and then you can add or subtract, you can use synthetic division. So first off, the same rules apply. If you are missing something, you still have to have placeholders of 0. So whenever I do this, okay, I'm going to draw my box, but instead of drawing it with the vertical or the horizontal line on top, it's going to be the opposite. Now, in this case, my highest power is the third. So I'm going to have my x to the third here. Now, you don't have to write this. I'm just going to put it just so you kind of know what I have. I have an x. I have a constant. Only thing I have to look for, once I know how many I have, so x to the third, x to the second, x constant, so on and so forth. Okay? It may go out to x to the fourth, it may go out to x to the fifth, whatever. So along that top line, I want to leave myself enough space, basically, so I can have 2 rows. Okay? I can have a row up here, and then I can have a row down here in orange. So you want to leave yourself enough room. Okay, so leave yourself basically 2 rows if you're using regular paper or line paper. Everything that goes in the yellow is going to be my coefficient of that power. So what number is in front of the x to the third? -1. So I'm going to have -1. What number is in front of the x squared? +4. If you need to write a positive, write that. That's fine. What number's in front of x? 0. There's not one. Okay, so just like whenever we did regular division, you have to have a placeholder, and we have to have 0. Then, what is my constant? What is my value that does not have an x with it? A +9. Now, whenever we do synthetic division, okay, we're dividing by x minus 3. So what that means is, if we would set this equal to 0, what would my x value be? If we said x minus 3 equal to 0, what would x be equal to? 3. Okay? Now, in some cases, whenever we get later into this, they're going to give you the value for x. They're going to say, hey, x is 3. Okay? Whenever we're dividing, though, it's going to be x minus, x plus a number. Okay? If it is dividing and you have x plus or minus a number, it's essentially going to be the opposite value. Okay? So that 3 that we have right here is going to go right out in front. Okay? Just on the other side of that -1, but on that same row. Now, first thing I have to do, okay, just like we did before, okay, similarly, I'm going to take that first term every time, no matter what it is. I don't care if it's a -1, I don't care if it's a +3, I don't care if it is a +72. We're going to drop it like it's hot right here. So the lead term, no matter what it is going to go straight down. I'm not going to fill anything in that orange blank. I'm going to bypass that line and put a -1 right down below. Now, it just becomes being able to multiply. Anything that is outside the box is going to get multiplied. Anything inside the box is either going to get added or subtracted, depending on what you have. So, what is 3 times -1? -3. That -3 is going to go right here. So 3 times -1, I'm going to put it right underneath that 4. I'm going to put it in that next open space. Okay? What's going to happen is it's going to look like a zigzag. If you would continue to draw the arrows, which I'm going to do, okay, it's going to look like a zigzag. So now I'm going to take 4 plus 3, or 4 minus 3, excuse me. So what's 4 minus 3? +1. You can just write it as 1, or you can write it as +1. Now, I'm going to take the 1, and I'm going to multiply it with the 3. So what is 1 times 3? 3. Yeah, I'm not trying to trick you, I promise. So the next spot, we just went up into that orange row. We went 3 times 1, and we got the +3. Now we're just going to go right back down and fill in our next spot. So, what's 0 plus 3? +3. Now, we're almost there. What am I going to do with +3 and +3? Multiply it. What's 3 times 3? +9. Now, straight down. So I got that by multiplying. So that's how I got the +9. 9 plus 9? 18. Now, there is a plus behind that, just so you don't lose it. or think that I'm changing things on you. Now, I'm out of space. Okay, I have nothing else to multiply because I don't have anything else. It's like I ran out of room. So, whenever I do this, whoop, always work backward. This is the one time that I'm basically going to start on the right and I'm going to go left. Okay, so whenever I do this, here's my remainder, there's my constant, there's my x squared. Always start with your remainder. It may zero out and you may not have a remainder. That's okay. If I don't have a remainder, you'll just leave it blank. You won't have to put anything there. But I always want to start with my remainder. The furthest value to the right, whether it's a 0 or any other number, that is your remainder. Remainder, then a constant, then an x squared. Okay? All I'm going to do is just rewrite this, and I'm just going to slide that number in front of every single x value, so negative x squared plus 1x plus 3 plus 18 over x minus 3. Now, where did I get the x minus 3 at? Okay, where did I get the x minus 3 from? What we divided by, right? Same thing. What are going to be the numbers that are going to go across in the yellow box, or the yellow line? Positive 3, negative 2, positive 2, negative 5. What number is going to go out in front over here? Negative 1. Okay, why is it a negative 1 and not a positive 1? Because it's the opposite of that, whatever that sign is. Now, what do we do with the 3? Drop it like it's hot. So, 3. What are we going to do with the 3 and the negative 1? Multiply it, so I'm going to get negative 3. Negative 2 and negative 3 gives me a negative 5. What am I doing with the negative 5? What do I need to multiply it with? The negative 1. So negative 1 times negative 5 is positive 5. Straight down, 2 plus 7, or 2 plus 5, excuse me, is 7. 7 times negative 1. Oh, positive 7, not negative 7. So, straight down, negative 12. Always start from the right side with my remainder, my constant, my x, and my x squared. So whenever I write this, 3x squared minus 5x plus 7. Now, here's where it's really up to you what you do. You can either write this as plus and then negative 12 over the x plus 1, or you can write it as minus 12 over x plus 1. That works here. All we did was just slide that negative out in front, or you could write it as 3x squared minus 5x plus 7, and then plus a negative 12 over x plus 1. Either way works. They both mean the same thing. But know that I would say most people, since it's a negative, they're going to put the minus out in front. They're going to do the one that's in the box. Maybe, maybe not. But know that I'm okay with taking either answer. Okay? What you would probably see normally if you would have some sort of multiple choice part on that, it would be a minus. Okay? It'd be a minus and then a positive 12 on top. So if you have 5x to the third minus x squared plus 13x plus 29, and it said to evaluate it for when x is negative 4. So they give us negative 4. Basically what this does, it gives you another option to plugging and chugging. Okay, some of you, if it said to evaluate here, what you would do is you would go 5, whoop, that's not what I want. You would go 5 times negative 4 to the third power minus negative 4 squared plus 13 times negative 4 and then plus 29. You can do the same thing with synthetic division, or what I call synthetic substitution. Now, it tells us what x is equal to, so we can put negative 4 out here. Again, I can, if I'm going to stick with my colored areas, so then hopefully that helps. The numbers that are going to go across are going to be 5, negative 1, positive 13, and positive 29. With synthetic substitution, or what's called the remainder theorem, I'm really only looking for one thing. It's the number that's down in that. It's basically whatever my remainder is. Whatever my remainder is going to equal the same thing if I plug it in right here. Okay? It just is giving you another option. So I still do everything the same way. I'm still going to take 5 and drop it. I'm still going to take negative 4 and positive 5 and get a negative 20. Still going to add straight down and get a negative 21. I'm going to take negative 21 times a negative 4, and I'm going to get a positive 84. I'm going to add straight down here and get 97. And then I'm going to multiply 97 and negative 4 and get a negative 388. And then add straight down, so a negative, I have to make, how much? 359? 359? Yeah. If I would plug in the negative 4 into my equation, I'm going to get the same thing. Okay, same thing as if I would have done everything up here in the box. Yeah.
Do you need placeholders?
Finish the assignment that you were given yesterday from Canvas. So then today is Tuesday. Everything will be due on Thursday.